Hey guys, let's continue from question 11. It says the diagram shows the structure of a wind-pollinated flower. And this is the structure here, okay? And you asked which part produces pollen grains. And just a little bit of breakdown. Pollen grains, they're the male gametes, they're the male sex cells. And they're produced by the stamens, okay? They're produced by the stamens. So our answer is actually D, because those are the stamens. And yeah, let's quickly move to the next part. And before we move, let me just show you. These are wind pollinated flowers, but then there are also insect pollinated flowers. So I just want to show you insect pollinated flowers real quickly. So these are insect pollinated flowers. So question 12 says the diagram shows the transfer of substances between the placenta and the uterine wall in a pregnant woman. Okay, so the placenta is this one, the umbilical cord is this one. So the baby would be this side here. The baby would be feeding through the umbilical cord. So the substance carried in the direction shown is, so the direction shown, it's upwards. So it's actually away from the umbilical cord. So whatever is getting away from the umbilical cord, it must be waste. So you can start eliminating oxygen, because oxygen is not waste. You can eliminate glucose, because it's not waste. We can eliminate antibodies, because antibodies they actually get from the mother to the baby. So the answer here would be A, this one here, urea. Urea is the substance in urine. So, and let me just show you quickly a picture of the placenta, what it looks like. So this is the placenta here. I think it's a human placenta, I think. So this is the umbilical cord, and you can see there's it's a vascular network. It's a network of blood vessels. So it's very extensive, because the fetus will want intensive general support to take in nutrients and also to take out any waste products. So some cultures actually eat this placenta. It's called the pig in bed. So you put it in a freezer and then they eat it just because it's that nutritious. So most animals they eat the placenta after birth. But I just wanted to show you real quickly so that you can have at least some visualization of some of these things. Let's quickly move to the next part. It says the diagram shows the life cycle of an Anopheles mosquito. So this is the life cycle. Which method can effectively control the mosquito at stage J? Okay, so these are eggs. Okay, this is a larva. These are, you can say larva stage. I think that this one is a plural. I'm not really sure. This one is called a pupa, and this one is called a adult mosquito. There's another name for it. I'll tell you real soon. But you asked which method can effectively control at stage J. So you want to, stage J is this one here. So you want to control this. How can we do this? So these are like they reside in standing waters. Okay. So if you have anywhere where the water is not flowing, you find mosquito larvae. And what you do is you cover that with oil. And when you cover that with oil, they don't have grills, so they can't. They will suffocate, and then they won't be able to reach the pupa stage. So the correct answer would be covering water ponds with oil. This one here. Okay, cutting grass at home, cutting the grass around the home would be for the pupa stage, and also to spraying insecticide and using mosquito repellent. It would be to control the adult stage here. Let me show you a bit diagram for this. So the better diagram would be this, and this is the imago. Imago it simply means adult insect. So, and then these are the eggs, the egg stage, and then the larva. It's all this. These stages are the larva stage, and this one is the pupa here. It's got this hard coating and all, and then you reach the adult stage, the imago. So let's quickly move to the next part. Next part says active immunity may be developed by. Okay, this is like you should know this. It's better for you to know rather than try to eliminate for at least for this question. So active immunity, it's developed by suffering and recovering from a disease. Okay, so when you suffer, let's say you have COVID, when you recover from COVID, at least for some time, what happens is that you'll be resistant to COVID. So you have some immunity from COVID. So by recovering and by suffering and recovering from a disease. So we check 14A. Let's quickly move to the next part. Next part is 15. It says Avogadro's number is the number of. This is again something that you should know. So let me just give you a brief background. If you want to count things in quotes, of course, if you want to count things in science, you can use either the mass, quantify substances in science. You can use either mass or an idea called the mole. Okay, so this mass here, it uses the kg. These are basic units, and this mole here, it's a quantity. It uses the mole. This is a count. Okay, so you can have 1 kg of cotton and 1 kg of gold. They weigh the same, but then they are different substances. Here you can have a count, 1 mole of something and 1 mole of something, 1 mole of gold and 1 mole of silver. They weigh differently. Okay, just because we are concerned more with the count here, count, physical count. You can have, for example, in principle, you can have a mole of pens. It simply means a specific number which is very, very big. That's what it means. Specific number of what? Of particles in general. It can be protons, it can be electrons, it can be neutrons, and that's why these answers, they don't fit. So the answer that would fit is particles. In principle, you can even have a mole of buses, and a mole simply means you have 6.02 multiplied by 10 to the power 23 particles. If you have this much particles, you can say that I have 1 mole. It's a way for us to keep numbers sane in chemistry, because when you're talking of electrons, when you're talking of atoms, there can be like so many in very little. There can be so many in very little mass. So that's why we use this concept of mole. So the mole means number of particles. The Avogadro's number is the number of particles. It defines the mole. Avogadro's number, we find it in thermodynamics. Let's quickly move to the next part. Next part says the 2 subatomic particles found in the nucleus are. So found in the nucleus means they're also called nucleons. So they can ask you, what are the 2 types of nucleons? So nucleons that's the general term. It simply means residents of the nucleus. Okay, means residents of the nucleus. That's what it means for nucleons. Residents of the nucleus. So here, nucleon, it won't be possible, just because it's what can I say? It's an umbrella term. Okay, you want to find specific things. It'd be protons and neutrons. These are called they contribute to the mass. This one, they're not. This one and this one, they're not. And a big part of the reason they are not is that electrons, they don't reside in the nucleus. They are found in the orbitals. So you can start by eliminating this 2. And this one, electron also, you start by eliminating it. Then you're left with protons and neutrons. So that was another way to go about it. Let's quickly move to question 17. So it says the symbol, this represents an atom of oxygen. How many neutrons does the atom have? So a little bit background. This one will be called you can say nuclear number. Okay, just like we covered previously, that this is the nuclear number. In other words, this is the number of protons plus the number of protons plus neutrons here. Always, this is the standard notation. And this one is the number of protons. It's called the atomic number. So here you have P, protons plus neutrons, equal to 16. And you have protons equal to 8. So you can substitute 8 here plus n equal to 16. So n equal to it's equal to 16 minus 8. 16 minus 8 is simply get 8 here. So number of neutrons would be 8, like this. Okay, let me show you the atomic model. The atomic model is this one here. So yeah, so this is the atomic model that we currently use, and these are electrons. Okay, you find them in orbitals, and these are, you can say, protons here. These are protons. These are, you can say, neutrons here. So these are the three basic subatomic particles. So you have this, they're found in orbitals. These orbitals, they're kind of imaginary. This is the these orbitals, they don't exist physically. They're kind of imaginary here. They're just paths that the electrons follow. And this one now is the nucleus. This whole thing here. The nucleus is relatively small. It's very, very small compared to the radius of the orbital. Okay, so that's it. Let's move to the next part. Next part says, what's the relative molecular mass of water? So here, relative, just a little bit of background. Relative means we are comparing it to an isotope called carbon 12. Okay, so carbon 12, it's the standard. That's what we use, and we define a 12th of a carbon atom. Isotope, it's a specific type of carbon, and we define that as one mass unit. Okay, that's what we do. And when we have a molecule, we can add those individual mass units to get the mass unit of the molecule. It's called the molecular mass. So for example, this one, you have to identify that you have 2 hydrogen atoms and you have 1 oxygen atom here. So 2 hydrogen atom, it's with 1 unit, mass unit. Okay, plus here it's oxygen, it's 16, so it actually get 18 here. Okay, it's usually grams per mole, but let's just right, since it's relative, we just need to define it as such. So here we get 18. Let's quickly move to the next part. Next part says the diagram shows the bonding in a compound XY, and then you're asked to identify the bonding. So here there is transfer of electrons. These ones, these spheric solid ones, they belong to this. We call it an element to element Y. Okay, so we can say that this element, it's generally, it means that this element here, which has lost electrons, it's usually a metal. Okay, because metals, they're not really good at keeping their electrons. We say that the electronegativities are very low. And then this one which gained, it's usually non-metals, because non-metals, they love electrons so much. And when you have non-metals only bonding, they kind of have more or less the same power in terms of how they attract the electrons. So at the end of the day, they end up sharing, and we call it covalent bond. But in our case, we had complete transfer of electrons. So here would it's called ionic bonding. Okay, covalent between non-metals, normally metallic bonding. Just the metallic elements, there's metallic bonding. Hydrogen bonding, you find it in non-metals as well, usually compounds that have hydrogen in them. That they have hydrogen and some other element which is highly electronegative, or that likes electrons so much. So this one wouldn't fly. So we'd have ionic bonding. Let's quickly move to, I think, the last part, the last question. Last question says, which product is formed when a metal reacts with air? So you can have a metal plus air. When they say air in chemistry, they actually mean oxygen. Okay, just remember this. So anything formed from oxygen is usually what? An oxide. So we say that the metal, it will be a metal oxide. It can't be a salt. Salt usually neutralization reaction. Then a carbonate, sometimes neutralization reaction reacting with carbon dioxide, then hydroxide, yeah, it won't lie. So you just need to know that it's an oxide here. Reacts with air, the clutch is that air is oxygen. And that's it. So that's it for this part. Next, in the next video, we'll look at questions 21 to 30. Thanks for watching. Cheers.